Hi everyone, welcome to RoshChem summary videos. In this video, I'm summarizing the lesson pH calculations. So we'll see how to calculate the pH of a strong acid. So for example, how to find the pH of 0.001 molar HCl solution. So we know HCl is a strong acid. So first thing is to write the ionization of the acid. So which is HCl plus water is giving H3O plus and Cl minus. Right. So then now I know it's given the concentration of HCl is 0.001. So then I can find the H3O plus concentration. So if you look at the ionization equation, the coefficient of HCl is 1. The coefficient of H3O plus is also 1, which means it's 1-to-1 ratio. So if the concentration of HCl is 0.001 molar, the concentration of H3O plus is also 0.001 molar. The two concentrations are equal here because it's 1-to-1 ratio. So now I can say pH equals to negative log of H3O plus concentration. Now I calculate the H3O plus concentration, which is 0.001. So then I get, so negative log of 0.001 is 3. So the pH of this solution is 3. Okay, now we'll see how to find the pH of a base, a strong base like sodium hydroxide. So first thing, I break down my base given, or else I write the dissociation of NaOH to Na plus and OH minus. So this reaction is called dissociation. So now what information I have? I got the concentration of NaOH as 0.001 molar. Therefore, the OH minus concentration is also same because it's 1-to-1 ratio. Now to find the pH, I need the H3O plus. So therefore, to find the H3O plus, I can use the Kw equation. So the Kw equals to what? H3O plus concentration times the OH minus concentration. So then to find the H3O plus, I can say H3O plus concentration equals to then what? Kw divided by the OH minus concentration. So now I know the Kw value is 10 to the power negative 14. Then you divide by the OH minus concentration I found here, which is 0.001. So therefore I get H3O plus concentration as that, 1 times 10 to the power negative 11. So therefore I can now say pH equals to negative log of H3O plus. This is the pH equation. So now H3O plus I know, so then I get pH as 11. So this is how we find the pH of a base. Okay, so then the next one is, if the pH is given, how do you find the concentration of the acid or the base? So we have this equation, H3O plus concentration equals to 10 to the power negative pH. So look at this question here. Calculate the concentration of HCl if the pH of the solution is 4, right? So H3O plus concentration equals to what? 10 to the power negative pH. So then negative 4. So 10 to the power negative 4 means 1 times 10 to the power negative 4 molar. So this is the H3O plus concentration, but it's asking what is the concentration of HCl. So we know the ionization of HCl. So this reaction is giving H3O plus. So in this reaction, the ratio is what? 1-to-1. So 1 HCl, 1 H3O plus. So if you know what is H3O plus, which is 1 times 10 to the power negative 4, that's the concentration of H3O plus. Therefore, the HCl concentration will also be same 1 times 10 to the power negative 4 molar. So this is how you find the concentration of the acid when the pH is given. Okay, then the effect of a dilution on the pH. So what will happen to the pH when you dilute an acid or a base? So look at the question here. 10 ml of 0.02 molar HCl was diluted to 100 ml. What is the pH of the undiluted solution? and what is the pH of the diluted solution. The original solution's pH, I can first calculate, right? So I know pH equals negative log of H3O plus concentration. Your original HCl's concentration is 0.02, which is same as the H3O plus concentration because it was 1:1. So therefore, negative log of 0.02 gives you 1.7 for the original HCl solution. So now you do a dilution. So from the dilution, for the dilution, I can use C1V1 equals to C2V2. So now I can find the new concentration of HCl after the dilution using C1V1 equals to C2V2. So C2 equals to, then C2 means the diluted concentration equals to 0.02, that's the C1 times V1 divided by the second volume. That gives you 0.002 molar HCl. So this is the concentration of HCl after you dilute. The concentration of H3O plus will be same. So now I can use pH equals to negative log of H3O plus. Now H3O plus is same as HCl, which is 0.002. Therefore, I get pH now 2.7. So what has happened? Initially, the pH of the acid was 1.7. So now when you dilute, the pH has increased by 1 unit. So it went up to 2.7. So dilution of an acid will increase the pH. So like that, the dilution of a base will decrease the pH. Okay, so this table shows the how when you dilute an acid or a base, how the pH is changing with the dilution factor. So dilution factor is by how much you dilute. So if you do a 10 times dilution, like in the previous case, you had 10 ml acid and you dilute it up to 100 ml, that's a 10 times dilution, right? The pH will change by 1 unit. If it is a 100 times dilution, the pH will change by 2 units. If it is 1,000 times dilution, it's 3 units. So because it's an acid, the pH is increasing when you dilute. For bases, the same numbers, but the pH is now decreasing when you dilute. So that's the end of this video. So you can try questions from RoshChem 1 and 2 study guide. You can find questions and summary notes on pages 92 to 97. And thanks for watching my video. So if you need any further information, please visit our website www.roshchem.com. I will see you in another video.